Our second example is another parabola in standard form, ax squared bx plus c. Does it open up or down? Well, let's check our a value. Our a value is negative, so this one's going to open down. Our axis of symmetry is found by doing opposite b over 2a, because that's how we find the x value of the vertex. Remember, it's a line, so it needs to start with x equals. Our b is 3, so opposite of 3 is going to be negative 3. And 2 divided by a, which is negative 1. So negative 3 divided by negative 2. Both of those are negative, so they cancel, and it becomes 3 halves. So x equals 3 halves. So 1.5, here's my line for my axis of symmetry. Draw that in as a dashed line. And then the vertex. The x value is very easy to find because I just found it, so we just bring that down. And now we need to find the y value. In order to find the y value, we're going to plug this 3 halves in for all the x values. So we've got the opposite of 3 halves squared plus 3 times 3 halves plus 1. So 3 halves squared. 3 times 3 is 9. 2 times 2 is 4, and we need our negative there. 3 times 3 is 9, so this is 9 halves plus 1. If we add these together, 9 fourths, 9 halves, and 1, we will get 13 fourths. Then does this one have a maximum or a minimum? Well, since it opens down, it's going to have a maximum. And the value of our max is the y value of our vertex, so 13 fourths. My y-intercept I find again by plugging in 0 for x and solving 0 plus 0 plus 1. So it is 0, 0, 1, because I forced the x to be 0, and I got a y value of 1. Then the x-intercepts, remember we can try to factor. This one doesn't factor though. So our other options are completing the square or quadratic formula. So I'm going to do quadratic formula. So it's x equals opposite b, negative 3, plus or minus the square root of b squared, 3 squared, minus 4 times a, which is negative 1, times c, which is 1, divided by 2a. I'm going to need some more space for this. Let's keep going. Negative 3 plus or minus, okay, 3 times 3 is 9, negative 4 times negative 1 times 1 gives me a positive 4, and negative 2. And I'll move over here somewhere. Negative 3 plus or minus the square root of 13 over negative 2. Interesting. So when we split that, if I do negative 3 plus the square root of 13 divided by negative 2 would be one of them, and negative 3 minus the square root of 13 divided by negative 2 would be the other. Negative 3 plus the square root of 13 divided by 2, I've worked out earlier, that is negative 0.302. Negative 3 minus the square root of 13 divided by negative 2 is 3.302. When I write them as x-intercepts, I'm going to write them in their fraction form. Negative 3 plus the square root of 13 over negative 2, 0. And negative 3 minus the square root of 13 divided by negative 2, 0. But I need them in their decimal form so I can graph. So let's go ahead and graph everything. The vertex is at 3 halves, 13 fourths. So 13 fourths would be 6 1/4. And then my y-intercept is at 0, 1. And my x-intercepts, oops, that's positive. Wow. I apologize. Sorry. I went down when I should have gone up. Over 3.5, up 6 1/4. Wow. Then here's my y-intercept, and my x-intercepts are at negative 0.302 and 3.302. 0.302. And I can get this point right here as well because it would be symmetrical, and I can go over 1, down 1 to just get some more points so I can graph that in a little more accurately. So there's my parabola. Now I need to look at where it is increasing and where it is decreasing. So put your pen along the paper, drag it from left to right. As you encounter the parabola, it is increasing. So we're going to start with increasing. We came from the left side, so it is negative infinity. And we increase until the vertex. So we find the x value of our vertex at 3/2. And then it would be decreasing from 3/2 all the way to the right, which is positive infinity. Notice these infinities they are not both negative. It doesn't have to do with them pointing down. It's going from left to right. It doesn't have anything to do with up and down. Where is my graph positive and negative? So again, slide your pens along. First thing I encounter is the graph being below the x-axis, so that's negative. Coming from the left, negative infinity, until this x-intercept. Now this x-intercept was going to be the negative 0.302, so negative 3 plus the square root of 13 divided by negative 2, and then that's where, sorry, shouldn't have started that one. Ignore that one for a second. Then it's positive, so over here under positive, I'm going to write that same thing, negative 3 plus the square root of 13 divided by negative 2, and it is positive until this next x-intercept, which is negative 3 minus the square root of 13 divided by negative 2. And at that x-intercept, it goes negative again, so over on my negative side. And it keeps going negative until we're off the page to the right, so infinity. And then domain, easiest thing on a parabola, negative infinity to infinity. And range on this one, bottom to top, so the bottom, I encounter arrows, so that's going to be infinity from the direction I came from, which was the bottom, so it's negative, all the way up to the top value, which is my 13/4, and the parabola actually exists. There's a point at 13/4, so it gets a bracket.